Hello, everybody. So today is Monday, and here's the lesson. So this is me. I am thinking about a angle theta. I'm thinking about an angle theta, and I only have one little clue. The only clue I have is that the cosine of that angle equals negative a half. That's the only thing I know. So what angle could I be thinking of? Well, since cosine equals negative a half, I know that the x value on the unit circle equals negative a half. So I could be thinking of this angle, which is 2 pi over 3, because 2 pi over 3 has an x value of negative 1 half. But I could have been thinking about 4 pi over 3, because 4 pi over 3 also has an x value of negative 1 half. Or I could have been thinking about, what is this angle? Negative 2 pi over 3. That angle has a cosine of negative 1 half. Or I could have been thinking about, what is that? That's 2 pi, right? That's 6 pi over 3 plus another 2 pi over 3. I could have been thinking about 8 pi over 3. 8 pi over 3 has a cosine of negative 1 half. Or finally, let me go backwards. That's backwards one circle. So negative 6 pi over 3, negative 12 pi over 3, negative 14 pi over 3. That too has a cosine of negative 1 half. And so I hope you can realize I could go on and on and on and on and on. I'm finding some of these are coterminal angles, but what they all have in common is that their x value, where they stop, the x value is negative 1 half. So what I'm really doing here is I'm kind of thinking backwards. Cosine is a function that receives an angle measure, but I want to reverse that. I want a function that will give me the angle measure, that produces the angle measure, if I tell it that the input is negative 1 half. And so you see what happens? Do you see what has happened between these two equations? The domain and the range switched. Where have you seen that before? When the domain and the range switches, you've seen that with inverses. That's what we're talking about today. Cosine has an inverse, so does sine, so does tangent. And just like any other inverse, it reverses the domain and the range. So when cosine receives an angle, cosine inverse will result in an angle. When cosine results in an x value on the unit circle, cosine inverse will take in the x value on the unit circle. So everything gets reversed. But there's a problem, because I want cosine inverse to be a function. I want cosine inverse to be a function. And the number one rule, the only rule functions have, is that when it receives something, it can only produce one thing. But look, I've got 1, 2, 3, 4, 5 different answers, and I could have gone on and on and on. That's not a function. I can't take the cosine inverse of negative 1 half and get 5 different answers. So we have to restrict the domain. This is exactly what we did last year in November and October when we talked about inverses. You switch the domain and the range, and you have to restrict the domain sometimes. It equals the range on the original, things like that. So here is how they are traditionally restricted. Cosine inverse is also known as arc cosine. I'm sorry to say, they're pretty much equally used. So arc cosine and cosine inverse are the same thing. Sine and arc sine are the same. Tangent inverse and arctan are the same. And the range for cosine is between negative pi and 0. That's what cosine inverse will produce. Any angle between, why did I say? I knew I was making a mistake. From 0 to pi. I was just thinking backwards. From 0 all the way to pi. That's the range of cosine inverse. It will produce any value between 0 and pi. Arc sine will produce any angle between negative pi over 2 and pi over 2. So anything from down there, from negative pi over 2, all the way up to positive pi over 2. And arctangent has the same range value. So now that we are equipped with this information, knowing that cosine inverse can only produce angle values between 0 and pi, which one of these 5 is my correct answer? It is only this one. And so that allows us to have a unique range value with every domain value. And so that makes it a function. Well, let's practice. So I want to find arc sine of rad 3 over 2. So I'm thinking, what angle has a y value of rad 3 over 2? Because sine is y, right? So what angle has a y value of rad 3 over 2? Well, when y is rad 3 over 2, you're right there. Of course, there's this big angle that has a sine of rad 3 over 2, but that's outside of my arc sine boundary. So I want to focus on this angle, and that is the angle pi over 3. So pi over 3 has a sine of rad 3 over 2, and that is the unique answer to arc sine of rad 3 over 2. What about this one? Cosine inverse of negative rad 2 over 2. So what angle has a cosine of negative rad 2 over 2? Well, we know a lot of them do, but to restrict them, so we have a function. It's this angle. Remember rad 2 over 2 was the 45, the pi over 4 angles. So I want this angle. This angle right here has a cosine of negative rad 2 over 2, and that angle was 3 pi over 4. So it goes without saying that we have to be comfortable with our unit circle. Tangent. What angle has a tangent of negative rad 3? Negative rad 3 is the one down here. This has a tangent of negative rad 3, and this angle rotates down. That is negative pi over 3. Negative pi over 3, the tangent of negative pi over 3 is negative rad 3. The tangent of negative 1 is negative pi over 4. The pi over 4s for tangent are either 1 or negative 1. And bringing out the unit circle, things become a little bit more clear. Let's do this tangent one of negative rad 3. So here, 5 pi over 3 has a tangent of negative rad 3. 5 pi over 3 does. But 5 pi over 3 is outside of the range of tangent, because 5 pi over 3 would be that. And that's outside of the range of my arc tangent. There's another way to get right here. There's a faster way. Just go down pi over 3 instead of going all the way around to 5 pi over 3. But the whole thing is predicated on the fact that you know that negative rad 3 for a tangent value occurs right here. The other tangent of negative 1, well, tangent 3 pi over 4 has a tangent of negative 1, and so does 7 pi over 4. They both have a tangent of negative 1. But remember, for tangents, we want these angles only these angles. It is not 7 pi over 4, because 7 pi over 4 is this big one. How else can I get to that spot? I can go down just 1 pi over 4. So that's why the correct answer is negative 1 pi over 4. Let's do cosine inverse of 1. Cosine inverse of 1. Well, where on the unit circle is the cosine positive 1? Right there. Ugh. Right here. The x value is positive 1 right there. So you may think you got lots of options. You've got 0, 2 pi, 4 pi. All of those angles have a cosine of positive 1. But if you look at your restrictions on cosine, you only have the first 180 degrees. You have 0, 1 degree, 2 degrees, 90 degrees, all the way to 180 degrees. So do any of those angles have a cosine that equals 1? Yeah, only one of them does, the cosine of 0. So that's why this answer is 0 right here. And then this is negative pi over 3. For this sine inverse, you're looking for a y value. I'm sorry, you know that the y value is negative rad 3 over 2. So imagine in your head, there's a unit circle. The y value of negative rad 3 over 2 is down there. And what angle meets this spot right here on the unit circle? So this is just a matter of knowing our unit circle, and it is, again, another negative pi over 3. What angle has a cosine of rad 2 over 2? Pi over 4 has a cosine of rad 2 over 2. What angle has a sine of negative rad 2 over 2? Lots of them do. But we can only answer one correct question to make sure that this is a function. It's a rad 2 over 2, so it's the 45s. So it's anything here or here. And for sine inverse, for sine inverse, only the angles between negative pi over 2 and positive pi over 2 are acceptable. And so therefore, this is the one that we want, and this is negative pi over 4. So again, going back to this page right here, for inverse cosine, it's only the first 180 degrees, from 0 radians all the way to pi radians, from 0 radians all the way to pi radians. For sine, you start at negative pi over 2, and you go up all the way to positive pi over 2. You see how this covers all possible y values? It goes all the way down to the y value of negative 1. It goes all the way up to the y value positive 1, and it includes every y value in between. Just like with cosine, you get to go all the way to the left to negative 1, and you get to go all the way to the right to positive 1, and it covers every x value in between. And then this one, which angle has a tangent of negative rad 3 over 3? The unit circle has really got to be inside your brain. The rad 3 over 3's for tangent are the pi over 6's. The rad 3 over 3's are the pi over 6's. And the negative rad 3 over 3's are the ones with the negative slope. So I want this one right here, which that angle is 11 pi over 6, but you would say negative 1 pi over 6. Negative pi over 6.